Good morning, everyone. Thank you for joining us for the first session of Azure Data Week 2019 on the Azure Data Ecosystem. So we are ready to go. So John is going to go ahead and get started. If you guys need anything while presentation is going on, just type it over there in the chat panel. You ready, John?
Yes.
All right.
Okay, welcome everyone. Good morning and thanks for joining. We appreciate you attending the Pragmatic Works Azure conference. So with that, we'll go ahead and get started. If you can see my screen okay, what we're going to talk about today is the Azure Data Ecosystem best practices. A little bit about me, principal consultant with Pragmatic Works. Started with the computer back in the 80s. I've been working with data since about 96, and I've been consulting since 2000. I have a blog, and I reside in Tampa Bay, Florida. So what are we going to talk about today? Well, we're going to talk about the history of data, a little bit about the flow of the data through the Azure lifecycle. We're going to talk about some of the roles that are, required for the moving to the cloud, some change, some patterns, and some change management, as well as Agile methodology, and then perhaps a summary and some questions. So as we know, everyone that's involved in business today, data is the driving force behind the new economy. And by that, data is the new oil. So a long time ago, we had all this data that we accumulated through front end and client server applications. And the focus was on the development of these applications to serve some need, whether you're distributing goods or services or selling products. But now we've come to the realization that data is the gold mine that sits underneath the applications. And with that said, there's been a gradual shift to the cloud for good reason. The Azure Data Ecosystem from Microsoft has a ton of applications that you can use to manage your data through the life cycle. In doing so, there's some best practices and design patterns to help automate the data into a sustainable, scalable, and repeatable processes. And we'll go ahead and get started. So just some history of data. As we know, COBOL was one of the earlier languages, the mainframe, and the COBOL developer owned the entire ecosystem. He wrote the COBOL code. He saved the data. He or she saved the data to some files that reside on the mainframe, and he was the gatekeeper. So if anybody wanted that information, they had to go through the COBOL programmer, which meant you got to buy him coffee or some way to get that data. Along came these fourth generation reporting tools that made it easy to wrap a layer of query on top of the data and to distribute that data to people who make the decisions. So it became apparent that around that time that the data is a driving force, and that's where the value is. Then we had the data warehousing with the dimensions and the fact tables, and we used cubes to slice the data. There was some complexity involved. It was hard to find developers, and there was some cost associated, not with just building the cubes, but also maintaining them and support. And then big data came along, and we said, big data is going to solve all the world problems. And it was hyped as the next best thing, and it had tremendous value. And the reason it had tremendous value is because you could accumulate large sets of data, store them as files on the HDFS, and you had a plethora of applications so that you could do all sorts of stuff with the data. And unfortunately, the steam kind of wore off for a lot of reasons. It was too complex, and we came up with better solutions. And one of those better solutions is called Azure Data Ecosystem, which is a cloud-based data lake system. And it does a lot of the things that encompass these top ones up here. So you're probably thinking to yourself, why should I move to Azure? Well, there's a ton of applications. It's tightly integrated, and we centralize the data in the cloud. You can store your data in storage, and there's a low cost associated. But when you compute the data, as in you spin up some applications, whether it's HD Insight or Data Factory or what have you, then there's cost associated. But by doing so, when you compute the data, you charge slightly higher, but otherwise there's low cost. So that means that you can store a ton of data in the cloud. Obviously, disaster recovery. Living in Florida, if a hurricane comes along and wipes out the data center, hopefully you have some backups. But now that data is replicated perhaps across different regions, whether in the United States or Europe, and that's a huge benefit. It also allows for remove workers. So what that means is that no longer do we have to be in a cubicle with the other team and mandated. We can work remote. So you may have people in California, New York, Boston, Florida, what have you. And I would say one of the best advantages of the Azure Data Ecosystem is once you extract the data from the production system and move it to the cloud, you're basically disconnected from the original data source. So there's a ton of other vendors that allow you to store data, but once it reaches the Azure platform, you have the ability to transform that data as you see fit. So, I'm working on a project for a pretty big organization right now, and our task was to build out a global data ecosystem in the Azure platform. And in doing so, what you could do is you could spin up an application in a relatively short time and push it to production, and then you have to support that. And along comes another request. So you build another application. By the end of the year, you may have 12, 15 applications, which is a maintenance nightmare, as well as you're reusing some of the code and changing the patterns along the way. So by constructing an architecture up front, you're setting yourself up for automation, a repeatable process. You can segment the roles into different, aspects based on where you are in the chain of the data. It also makes it easier to maintain. There's an audit trail. You can apply security. And once the framework is up and running, it's easy to ingest new data sources. So on the project that we're working on, it became apparent that we had to segment the roles into specific functionality. So we have our architecture team, and they're tasked with designing and orchestrating the data flow and the movement and what pieces are required for the data lifecycle. But not only that, we also have an infrastructure architecture as well, because in Azure, there's so many components, and you need somebody that's familiar with the entire ecosystem and has the ability to stand those up for you. We also have an ingestion team, and they're tasked with getting data to the cloud. We have the engineering team, who basically performs the ETL and preps the data for consumption. And then you have the visualization team that consume the data. Because at the end of the day, somebody needs to look at the data and make decisions. So if we talk about the first role, the architecture team, like I said, we have the infrastructure and the data architect, and they each have different tasks. So, the infrastructure is familiar with the subscriptions, the resource groups. How do you want to name those, the naming conventions, so that it's meaningful? And then when you have different subscriptions, they won't overlap, and it's consistent and it's documented. They also set up the alert and monitoring, and there's also, with the shift to the cloud, initially you'd purchase the database, and the database would have tools, and there was an upfront cost. You had to stand up the servers, you had to pay for licensing, and a whole bunch of other stuff. But with the Azure, it's kind of like a utility where you're charged for consumption and storage. So if you don't use a lot, there's low cost, but if you use a lot, there's slightly more cost. And it's up to the infrastructure architecture to strategize on how to best do cost management. And the data architect, like we said, is responsible for the data flow design patterns, how you're going to store the code in source code repository, some data governance, and security. The second team is the ingestion team. So the ingestion team has a few different roles. They wear the BA hat slightly. So they're the ones tasked with, we have these 500 data sources that we want to ingest into a data factory through the life cycle. And here's the top 5. So we bite off a chunk and we say, go get the information, which means going to the business and asking, what is it we're trying to do? What data do we need to source in order to satisfy the need? And document it into a data dictionary. And then from there, they get the data to the cloud. So if you look at the life cycle, typically we have an on-premise source, but not always. And we pick up that data, flow it to the Azure Data Lake Store, into the raw folder structure, and then we perform file validation on that file, and we move it to another folder location called stage. And that's basically their assigned tasks. So we predefine what the roles are, they know their responsibilities, they're experts at it, and that's how we get the data to the cloud. The next stage in the data lifecycle is the engineering team. And they're tasked with basically setting up the plumbing of the architecture. And in our case, we are leveraging the Data Factory, which is similar to Microsoft SSIS if you've worked with that in the past, but it's slightly different. And it's a good tool for the cloud, and they're experts at that as well. Obviously, they have the data storage, so the files are moving from one place to another. Another great feature about the Azure stack is that we have access to Azure Databricks. And Databricks is a great tool. We're using it for validation routines to cleanse, dedupe, standardize the dates, move files, and it also has the ability to do advanced analytics and machine learning. We are using the tabular model, but not in all cases. And if we look at the data flow for the engineering team, they pick up that file in the stage and they move it to curated, which is another folder in the data lake. And we save it as a Parquet file. We wrap it in Polybase. It gets mounted in SQL Data Warehouse, and then we flow it to the tabular model. So that's basically the life cycle of the DevOps engineering team. And lastly, we have the visualization team. And of course, Power BI is a great tool. It allows us to slice the data, build models, self-service BI. We also have Power Flow, Power Apps. We're leveraging Power Apps, which is a nice asset included in the Azure ecosystem. And what I like about the Power Apps is that it reminds me of Visual Basic back in the 90s, where if you had some technical savvy, even the slightest amount, you could sit down and knock out an application in a couple hours. But they've moved it to the cloud now, so the Power Apps gives you the ability to stand up quick applications. In our case, we're pointing to either files that reside on the data lake, or we point to the Azure SQL database. And the reason we do that is within Power Apps, you can monitor who has access through Azure Active Directory, and that allows the Power users to go in there and modify like control tables or reference tables, and it's a great feature. They also have some reports to do exceptions. Like if you have a report and you may have a date of 2097 as a year, we flag that as an exception report. There's another tool called Logic Apps, and it's essentially a tool that allows us to kick off jobs and start and stop services. We talked about the Data Factory, and the Data Factory is similar to the SSIS, the integration services, but it does a lot more. We call the Data Factory, and the Data Factory calls a stored procedure. And the storage procedure is in the control table, and the control table returns a list of files that we want to transport into the lifecycle. So it picks up those files and it lands it in the raw folders with no changes or modifications. And we also store off an audit trail in the SQL database, whether the task was success or failure. So we have an audit trail to go back in time and look at variables such as how long did the jobs take, success, failure, and a variety of other things. Within Data Factory, we have the integration runtime, which is basically how we connect to all the different sources. When you're working on an Azure Data Ecosystem project, this integration runtime can be installed on the network site, but in our case, we have networks all across the globe. So it made sense to, as a best practice, to create a virtual machine within Azure and monitor and allow it to live on the VM. Okay, Databricks we mentioned briefly, but it's a new tool. And this tool, it allows you to write your code in a variety of languages. It was built on top of Spark, so it runs on Scala. And you can also write Python as well as raw SQL. And it's a great new tool. And in doing so, we store the pertinent information in Azure Key Vault. And it's basically like a vault so that you can store a variety of information, and that way it's not exposed to other developers, and it's encrypted. Within Databricks, there's a new tool called Delta. And Delta does the heavy lifting for your extract, transform, and load. So in other words, you could bring in a petabyte file and process it through Delta, and it's going to churn through that data very quickly. And it's going, for us anyway, it's going to identify the inserts, updates, and deletes, which can then be flowed back into the lifecycle. We save it as a Parquet file from within Databricks, and then we mount it in Polybase to flow it into our data warehouse. With Databricks and Databricks Delta, it actually stores your data and does all its computation on a storage blob that's kind of behind the scenes. We don't have access to it, but if you shut down your compute within Databricks, your storage remains. So the next time you boot up, the data is still there. It's persistent. It scales for heavy volume, connects with Active Directory. And another nice feature is collaborative development. You know, it allows multiple people to work on the same code at the same time. But in addition, more powerful is that it allows you to put comments, like notes within the notebook, so that next time you come back, you can see, well, I did this because of this reason. It's a cool feature. And it connects to Azure DevOps. So in order for us to build out this global data ecosystem and to automate it as best as possible, we leverage something called control tables. And the control tables are driving factors that it tells the program just about everything it needs to know to get the data through the system. So our first control table is really the high-level information. It's like the file name and the source and the destination and the type. Is it a TSV file? Is it a CSV file? The domain of the, because you may have finance, accounting, HR, sales. So, you know, it keeps track of the domains so we can keep them together. Another nice feature is we have this error threshold. So as it's validating the file as it's incoming, we set a threshold per file. And if it exceeds the threshold, then we're notified so that we can determine if we want to let the file flow through or not. And an instance would be perhaps bad data or what have you. And we also have an active flag. And that active flag can basically toggle if the file is supposed to run or not. And that's maintained in the Power Apps. We have a second table, which is more of a low-level table. So let's say you have a file coming in from the payroll department, and the file contains 20 fields. So we link it back to table 1. We put the order of the fields that we're expecting in the CSV file with the field name and the field type. Does it allow nulls and some other variables as well? So we have the table structure of the incoming file, and that allows Databricks to scan this table in real time, because we can make a connection to the database, say what are the fields, what are the order, what's the type, and then we can compare the incoming file. So as we know, incoming data is never perfect. So maybe somebody fat-fingered a date as a string and it's invalid. So by knowing the field types ahead of time, we can loop through the columns and determine if there's errors or not. So that's one way that we automate it, through the control table. And the third one's basically an audit table. We also leverage the data warehouse, and it's a nice feature. It reminds me of the parallel data warehouse, the boxes, but it's not exactly the same as SQL database. There are some caveats. So, but the advantages outweigh that, and we create our dimension tables, our fact tables. It's scalable. You can apply your row level security. So for example, if you had a sales team, you would want the manager to see all the salespeople under his team, but not another team. And the salespeople obviously could only view their data, their quotas or their commissions, and then the director could possibly see all the sales teams. So that's how we do that. You can also mask sensitive data, such as PII or personal identifiable information, and a variety of other stuff. Now, you are charged in Azure based on the thing running. So what we do is we have these jobs that start it early in the morning and shut it down in the evening on our development server to save on cost. We also leverage the tabular model, which is sort of it's sort of the next phase of the OLAP cubes. And it is real easy to work with, and it's pretty easy to set up your data source, your relationships, your measures, partitions, and roles. It runs in memory so that when Power BI connects, It's pretty fast using a different, you have the direct query or the live query. And obviously, those of us in the data field for a while are familiar with Power BI. It's Microsoft's offering. It started out in Excel as some add-ins, and it's grown tremendously. It's grown like wildfire, and for good reason. We talked about Power Apps earlier. We do leverage the Azure methodology, as in our daily scrums. We have sprint refinement. We determine, what we're going to bite off for the next sprint, and then if it's achievable, and then we meet each day to talk about, what did I do yesterday? What am I doing? And the blockers. What I like about the Agile versus the waterfall. Waterfall is the traditional one where, let's say a COBOL developer got an assignment. He went away for 6 months and came back and delivered the final product. There was very little interaction with the business. With Agile methodology, the business is in the loop, up to date all the time. We also leverage Microsoft Teams for collaboration. So if you think about things to consider when moving to the Azure Data Lake, to the Azure Data Ecosystem, like we talked about earlier, the SQL Data Warehouse is not exactly like SQL database, but in this case, we don't always flow all the data to the data warehouse for various reasons. Perhaps we don't have a need for enterprise reporting on this small data set. So in that case, what we do is we move it to the data lake and we just leave it there, and then we wrap it so that it can be consumed through Power BI. Also, using that approach, once we pick up the data from on-premise, we flow it to raw, we validate the file using Databricks, we land it in stage. That stage file is deemed as good. So that means we can share that data with the rest of the organization. Data scientists to do their machine learning or advanced analytics. So that's a great feature also, because we have a history of the data going back in time, and we know that these files are good. It's disconnected from the on-premise source, so we aren't really too concerned about the original source of the database. We're concerned about the data and how we can leverage that to make meaningful decisions. Now, sometimes in order to expose that data to Power BI as a Parquet file, one method is to wrap the Parquet file in Polybase. And Polybase is a great feature from Microsoft, and it was originally used for Hadoop so that you could wrap a table, let's say in the Hadoop file system, and expose it through Polybase so that SQL Server allows you access to that data. It's pretty cool, and essentially you tell it the path and you tell it the file type, so that, is it a CSV file? What is the delimiter? Is there a header row? So once you wrap it in Polybase, it exposes it into the data warehouse, and from the data warehouse we can read that data from Power BI. And like I said earlier, once it's in SQL Server, then we can flow it to the dimensions in the fact tables and build out our data warehouse. So it's really powerful. So as an architect, one of the roles is to decide the naming conventions. Well, the infrastructure people have some design patterns that are required for standing up the subscriptions. And a subscription is basically like an account within Azure, and you can have multiple subscriptions. You can have one for dev, one for QA, and one for prod. And in doing so, what are the naming conventions that make sense, that are meaningful? There are some restrictions when naming your resources. Some have to be all lowercase, no spaces. Some of them have length requirements, can't be greater than a certain number of characters. So a lot of that you have to keep in mind. And that's the role of the infrastructure architect, to come up with some of these design patterns. Also within the Azure Data Lake store, which we've talked about, but we didn't really describe it. But if you compare it to the world of Hadoop, it's kind of like the file system, the HDFS, which is nothing more than a folder structure that allows you to store files. And the nice thing is it gives you a lot of freedom. The bad thing is that it gives you a lot of freedom, because there's the possibility of having file sprawl, where people are just landing files wherever they want, and it makes no sense. It's totally out of alignment. So it's up to the architect to come up with some strategy so that you can contain your file growth over time. Because as you're building these global ecosystems, it's not a 3-month project, it's a 3 to 5 year. And those files are going to live for a long time. So you want to make sure out of the gate that you're setting the proper standards and best practices to allow your system to grow. Because keep in mind, it's an automated system, and by defining the folder structure up front, we can store those values in our control table, and the data factory is going to read the control table, and it's going to build out that folder structure automated. So it's important to think about. So within any file system, like I worked at a place one time where we would convert a homeowner policy to a PDF, and then we would save it to a hard drive. Well, we had 1 million policies, and there'd be 1 million PDFs in a single folder. Now, obviously, that's not best practice, design practice, because it doesn't scale. And if you're searching for a file, it's ridiculously slow. So you have to determine what is the proper folder structure, how many layers deep you want to go. But not only that, how do you want the folder structure to be architected? And there's several ways. Some people would like to design the folder structure based on the source system. Oh, this data is from SAP. This data is from Lawson. This data is from HR. Not HR, Oracle, or some of the other vendors. Now, that's one way of doing it. Another way is domain. I'd like to segment by HR, sales, payroll. But what do you do if it crosses over within different domains? So there's a lot of considerations. But at the end of the day, you have to move forward with something. So it's important to think through these things, make sure that it's scalable and maintainable and repeatable. So with data, obviously security is a top concern because the data has so much information. If you want to make sure that the right people are looking at the right data at the right time. So luckily, Azure has about a lot of different ways to lock down the data, whether it's at rest, in flight, transit, actually within all the applications as well. For example, the subscription, that's kind of like the perimeter, and only certain people can get into the perimeter. And once they're there, what type of access do they get? Now, owner has tremendous access, so does contributor, but there's other. It's a really granular on how low you can go with the different permissions that you can assign to people. Within the data lake store, do you want everybody to see every file? Probably not. There might be payroll data or sensitive information. Same with the SQL database and data warehouse. What level of security do you want to assign to power users, developers, managers, external users? There's a lot of considerations. Same with the tabular model, as well as Databricks. There's a feature within the Azure platform because just about everything you do within Azure gets logged and recorded. And there's this mechanism so that you can dive in and run reports and see, what's happening. And it's very granular as well. And you can create reports and alerts. So let's say you set a threshold for your database, your data warehouse, and if it exceeds spike capacity for longer than an hour, we initiate an email so that someone can be notified and take corrective action. If you look at it over time, you say, well, on Fridays between 3 and 6, the thing seems to spike. So let's find out the root cause. And in the meantime, we can scale it up for that particular time frame. So with source control, obviously, this is important as well because you want to keep track of your code base over time, as well as see the versions and the iterations. I can remember back in college where my brother was an IT engineer student, and he was supposed to submit his application like the next day. If for some reason it got deleted, we couldn't find it. So we sat in the VAX room all night and keyed in the entire application from start to finish. So, that's a good use case so you don't lose your code. but it also keeps track of iterations. It allows collaborative coding styles. And when you create these Azure DevOps, which is cloud-based, you want to determine how you're going to create your projects and your repos. A repository. So for example, you may want an isolated repository just for your data factory, or just your Databricks, or just your Visual Studio Code. We're using Visual Studio 2019 for a variety of different products, such as tabular model. Another feature that I like is the SQL database project. So you can point the project to your Azure SQL database and bring down the contents of the objects. And you can select which objects you want to look at and store. And then let's say a week later, you say, well, I think the database has changed. So you can do a compare. And once you run this compare, it'll allow you to choose which file version you want to keep. So obviously, you'd probably want to bring in the most recent files. And then you can save them to the DevOps. So that's a great feature. However, it doesn't work with the data warehouse. So the method that we chose is that we store the objects within a Visual Studio project, and anytime a modification is made, it gets saved back to DevOps. So we can keep the entire model within the DevOps. You could also store your Power BI and your documentation within DevOps. Another key feature is data governance. With the rise of data, we need to keep a handle on it for a variety of reasons, not just because it's best practice or it's fun to do, but there's rules in place that you can be fined, for not having some of this stuff, like GDPR and data leaving certain countries and overlap. So with the data governance, we have these data stewards. Now, not all organizations are going to have this based on scalability, but some of the larger organizations have data stewards, and their basically main task is to ensure data quality, and they're also the resident data expert. And that person is highly valuable because they kind of know a lot. Some organizations have data governance board that, they say, what is the definition of a customer? What's the definition of a product? And they maintain that, and it has to go through the board to be approved. We've also seen the rise of the chief data officer, which is a valuable position because they're tasked with the data ecosystem. Sometimes they report to the CEO or the CIO, and perhaps there's overlap where you have 22 different vendors within your organization, which makes it difficult to maintain, find resources so they can consolidate, save cost, and what have you. There's also a product within Azure called the Data Catalog, which is real nice because it stores the objects. It's similar to a data dictionary. It's got a client that you can download, and you can do reporting off it there. So that's a good one as well. Okay, so within the Azure Data Lake store, you have to connect to the file system at some point from a variety of different tools. And one of them is the data warehouse. So we had to configure it so that the Polybase could actually read and write, read from the data lake, as well as the Databricks has access to the data lake. And we created a registered app. And also the Data Factory needs to connect. And what we use is the integration runtime. And then also Power BI needs to connect to ADLS. So it's fun to store your files and flow them through, but if you can't access it from anything, it's a problem. So these are some of the hurdles we had to overcome to get access and get the data flowing. So those of you who've worked in the data space for a while, most shops do it the same way as far as production bug fixes, for example. Well, if there's a bug, you just go in there and troubleshoot it, fix it, and you're done. But with Azure, it's locked down pretty good. So you kind of have to determine up front, what do you do if something breaks in production? Because someone's going to have to go in there and tinker and troubleshoot and look at the reports and figure out where the error occurred and how to fix it. So we need to determine what roles and securities allow people to fix production. Also job maintenance. Hey, this database is slow, or this there's a variety of different reasons why you would need somebody to go in there and investigate. And you need to think up front on the roles and securities. And lastly, change management. If I've been working on this project for 3 months and I want to pick it up and move it to QA or production, how does that occur? And who's responsible for it? Some organizations lock it down where nobody gets access to production except for the change managers. Other shops allow anybody. So it's just a matter of what fits your need. But what I'm saying is you need to think it through. And then, so like I said, Azure has so many components and features. It's it takes some effort to keep up with the different tools and how they change over time. And there's always more than one ways to solve a problem. So you could talk to somebody and say, hey, look at this architecture. Oh, you use logic apps. Why would you do that? Use the automation. So it just depends on, what are the industry best practices? What is the problem you're trying to solve? And what are the tools available that allow you to do that? And why would you select one over another? Why would you select database over data warehouse versus data lake? Why would you use Databricks ETL versus stored procedures? There's a lot of ways to solve a problem. But you need to think of long-term growth, and you need to make it flexible, adaptable, so that you could pivot downstream, as well as what skill sets are in-house. If you pick up a product and nobody knows how to do it, it's going to take some ramp-up time to get up to speed, not just to learn it, but to determine which is better, pros and cons, one versus another. So with the cost model in Azure, you're charged as you go based on storage and consumption and a variety of features. So it's very important to not only determine up front which tiers you're going to select when standing up an object within the Azure Data Ecosystem, because that's the upfront charge, but then how much storage do you have? How much compute time do you have? There's a variety of features that get lumped into the pricing model, and it's very important to keep tabs on that, because if not, it could run away a bit, and you want to keep close controls of the cost management. PowerShell is pretty important in the world of Azure. It's kind of behind the scenes, but you can do a lot with it for administration stuff. And documentation is also critical. It's the last thing that people think about on a project. It used to be reporting. Like when I started in '96 or so, we worked on $1 million project, and everybody was excited about the business rules and creating the upfront application. And then they got to the end and said, we should probably have some reports. So documentation reporting back then were kind of at a lower level. Obviously, that's changed where data is now probably at the top. But the documentation is still, even if you create this great documentation with visuals and all sorts of stuff, within the next day, it's possibly outdated. So it has to be a living document and updated frequently. So working on this global data warehouse, data ecosystem project has really shown that the industry is changing somewhat. I remember working back on client server applications where we would build the application in Visual Basic, and then someone came along and said, hey, we can wrap these reusable functions into a class. So that was great. Then they said, oh, we can bundle these classes into a DLL and put it in DTS transaction. So it kind of, you could see the growth over time. And then they said, oh, the web came along. We can connect to the web, to that same DLL from the client server and the web. So how cool is that? Same code reusability. Well, the web has taken off, especially Azure, and for good reason, because it's like a Lego block system where you have all these different pieces of different shapes and colors. And when you consolidate them together, there's so many possibilities. And depending on your use case, your organization needs and requirements, but all the tools are there, and it's growing every day. And it's important to get up to speed. And the other thing I like to say is that, with data, everyone thinks it's just this immaculate, perfectly world where there's no problems. But if you've been working with data for a while, it's probably the exact opposite. It's messy, dirty, and you're basically solving problems every day of your career. It's not a clean and simple, but that's the challenge. And that's also what's interesting and what I like about the data, because like one time I had to balance the books for 2 insurance companies. So that meant at the end of the month, everybody would log off and go home. And I would start work because I had to get the data to run. So I had to build the framework of how can I automate this month end so that it's streamlined as much as possible. Well, it would run for 2 or 3 days. I'd run all my reports, and then we'd look at the numbers and be off. They wouldn't match. And that's when the fun really began, because then you have to dive into the details. Oh, your numbers are off by $10. Oh, I'll just look for a $10 transaction. But it's never the case. It's probably off by like 2,004,000 in this direction and 1,998,000 in this direction. So once you identify the problem, then you say, well, how did it happen? Oh, somebody made a code change on Wednesday that broke it. Well, we have to back out that change, fix the bug, and rerun the month end. So the interesting thing about that is that it was a one-man show, and tasked with the month-end lifecycle and writing the code to get the results, and then validating the results and getting the commission reports to tie out. Well, with the world of Azure, what I've noticed is that it's more of a team sport, because there are so many components, there's so many moving parts, that one person, it's very challenging to actually even know what these objects are and applications, let alone put them together, let alone write the code and meet with the customers and figure out a strategy. So the thing about Azure Data Ecosystem, it is a team sport. And what we did on our project is we segmented the roles into specific tasks that people are required, responsible for, so that they can become experts. And at the end of the day, we have a framework in place. It's somewhat automated, and the data flows through. If it has an error anywhere along the trail, we can trap it and handle it and resolve it. And it's easy to maintain because everyone knows their roles and responsibilities, and we can add people to the teams, and we could also matrix people in from within the organization, whether it's business experts or IT experts. We can work with the data scientists to actually get some benefit from this data. But lastly, however long it takes to build this framework, once it's stood up, then the fun begins, because then you can start flowing those 500 data sources with relative ease, and the pattern's there, and it's already been flushed out. So once you sacrifice the time to stand up the framework, then you can start flowing in a lot of data. And Azure can handle that data, and it's designed for enterprise ecosystems. And there's so many different components across the board with machine learning and Databricks and tabular model and Power BI with Flow. There's a whole bunch of tools to get up to speed. But I would say that, working in data, it's fun to wake up each day and figure out what you're going to work on and solve problems for the client and to add value. Because at the end of the day, our job is to pinpoint the pain points for the customer or whatever organization you work for and solve those problems. So it's a real challenge, but it's a lot of fun. So at this point, that's what I wanted to talk about. And like I said, I really appreciate Pragmatic Works for giving the opportunity to talk at the conference. I know there's a lot of good information this week from some experts in the industry, and we appreciate everyone's attending. So Liz, do we have any questions, please?
Yeah, I know there was one. So everybody, if you want to start putting your questions in, that would be great. I'm going to try and find the one that was up at the top. Somebody wanted to know, are all the control tables created in Azure?
Yes, that's a good question. So our control tables are built in the Azure SQL database, and there's a few of them designed specifically for the flow of the data. But we also have other control tables that do other things. For example, when we're loading our dimensions and fact tables, we have a control table for that to identify, the names up front so that we know which files we need to import into the data model. So the control tables are actually the glue of the project, in that's how we automate things, by entering the data into these control files, and then the program knows to read that data, and then it says, okay, 2 o'clock in the morning, let's call the stored procedure. Oh, these 10 files need to be picked up. Where are they located? Oh, those are the on-premise location. Oh, let me have the Data Factory go and search for that file. Is it there? Yes. Okay, let's pick it up and move it to the data lake. If it's not there, chances are at 2:30 or 3 a.m. when it runs, it's going to look for that file again. Now, an interesting use case that came up is that there's some instances where it's not just one file. Like, you could have sales coming in from 5 different locations, and you don't want to pick up all the files until you have all 5 present. So we have an indicator in the control table that says this is a bundle of files, and that way it knows to pick up all 5 files. So there's a lot of creativity, and you can really leverage a lot. Also, with the data lake, we have specific naming conventions, and we have different nodes within the folder structure. So we predefine those. And then anytime you add a new data source, all we have to do is fill out a record in the main table. Say, what's the file? Where's it located? The file, is it TSV? Is it CSV? Who's the contact information in case the file goes wrong? And then we enter the contents of the data dictionary. Oh, there's 50 fields in this. There's these varchars and these ints and dates. So once we enter those 2 tables, we set the flag, we toggle it to true. All of a sudden, it just starts flowing. So, I mean, it's really powerful. So once you set up the control table of the infrastructure, you can really start pushing a lot of data. So I hope I answered that question.
Awesome. Now we've got a lot coming in now. Can we substitute Azure SQL DW with Snowflake for petabytes of data?
Well, I imagine so. I've heard a lot of good things about Snowflake. I've never actually used it. I know it's a component within the Azure ecosystem if you install it. We use the data warehouse, just because of ease of use and our familiarity with the, how things work. We like the scalability, so you can scale up or scale down depending on needs. You can lock it down with the data, with the Azure Active Directory. It reminds me of the parallel data warehouse in some aspects, because the way that it processes the data under the hood, by chunking and segmenting the data and unifying it back and sending result, it's pretty powerful. It can handle a lot of data. So I don't know enough about Snowflake to answer that properly. Sorry.
No worries. You talked about version control for Power BI, but if you're doing import, do you have processes to remove the data so the data is stored in source control?
Yeah, that's a good question. We're still in the preliminary on that one, but essentially we're just storing off the shell of the reports, and we're not doing data direct query at the moment, where we're not ingesting the contents of the model into the data, into the Power BI. We're just doing live connections, so it doesn't really store off any data.
Control tables are template tables provided by Azure, or is it up to project to build it?
Yeah, that's something homegrown that we developed, and so we created the table schema, the architecture team, and we kind of had a brainstorming session. What are all the possible fields that we would want to include in this control table? And it has changed over time depending on the needs and how the development goes. Sometimes we add or subtract. It is homegrown. You're not going to find it out of the box. You could put it in the data warehouse. You don't have to. The nice thing about the database in development is that the Azure SQL database is always on, and we have jobs to shut the data warehouse at night. So you always have access to the database. So they are homegrown things, but I kind of documented the outline on how it works with the main table and then the details, some audit trails, some validation. We use those control tables for everything. And the other thing I want to say about the architecture that we developed is that it has a built-in audit trail. So when these Data Factory pipelines run, before we initiate the call to the pipeline, we call a stored procedure that inserts a record into the audit table of the database, not the data warehouse. So we say, oh, we're going to perform this action. Here's the time, here's the date, here's the ID, here's who's running it, or what have you. After we execute the pipeline, we have the ID of the record that was just inserted, and we flag it as either success or failure. So you could imagine having a pipeline with like 50 sub-pipelines, and each of those 50 logs each time, and you can have loops. So you can imagine how much we're logging to the database, but there's a lot of benefits to that. There's an audit trail, so we can go back in time and look at patterns, look for like, oh, this file is failing on Tuesdays, or this one file always has issues. So the audit trail is another key component that's baked into the infrastructure, the architecture. So.
Okay. Someone wants to know if the framework is documented anywhere.
Well, we have document internally for the project that we're working on. What's nice about the Azure Data Ecosystem is that as more organizations are ramping up, they're looking for guidance and expertise, as well as people to implement that. And luckily at Pragmatic Works, we have several projects in flight that are doing that exact thing. So what that means is we have resident in-house experts, and there's people to go to ask questions. Hey, I'm running into this problem. Have you seen that? Oh yeah, I saw that. Here's how I solved it. So we collaborate internally amongst the team of experts, of MVPs and industry experts. So that's one of the benefits we have to get up to speed really quick on new projects, is we already have built-in frameworks and templates that are hashed out and validated in production. So I don't think we necessarily have it documented online at the moment.
You mentioned some data patterns best for Azure. Do you have a reference or model you recommend?
Well, this is sort of a high-level architecture of the pattern that we used and we've used on other projects. I don't necessarily have a documentation. We kind of piece, as we build out the components based on the client's needs, there are obstacles to overcome, and through a collaborative approach and best practices, we assemble the components to meet the needs of the business. And there's never two architectures that are exactly alike. They're similar. Some may use automation, some may use logic apps, some may use data warehouses, some may use Databricks. It's a good question, because with any new system, we set the pattern. Now, if you look at the existing data warehousing, which has been around 20-something years, obviously there's patterns that have been hashed out and thought through, and there are experts with 20 years experience that know everything you need to know about the abstract, the conceptual, how to build a model, what's the proper methodology. It's all documented and proven out. With the world of Azure, though, it's kind of like, whoever gets there first kind of has to overcome the problems. And then, yeah, you bring up a good point. It'd be great to document that and build white papers. And that's not a bad idea. But I don't necessarily know if we have any documentation online, but we could definitely assist and help. And as consultants, not only do we build stuff, but we also advise and recommend and project management and construct and architect. So we fill a lot of needs.
Okay. Is the traditional data warehouse model of fact table plus dimension table still applicable in the cloud?
I would say yes. There is a slight transition because, like I said, we don't use the data warehouse for every incoming data set. So what that means is we're leveraging the power of the data lake. So we have these new files that we ingest on a daily basis, or hourly, or monthly, quarterly. We validate those files, and then we move them to stage. Once it's in stage, we can then run a Databricks routine that, it can identify the inserts and updates. So it's doing your heavy ETL from small to petabyte scale. And then we save that file as a Parquet. Once it's in Parquet, that could be your dimension table. And then instead of having a fact table, we might have a transaction table that resides in the curated folder as Parquet as well. So there's no need to actually build the data warehouse. And if there's no data warehouse, we don't need a tabular model. We could just go, we could shortcut it from the Parquet file, Polybase, directly to the Power BI. So we've removed a good chunk of the development time. It has a lot of benefits. So I wouldn't say that it's not dead. I mean, we're still using COBOL. We're still using some of these 4th generation reporting languages. I don't think it ever dies. I think it just transforms. And there's so much legacy code out there. I don't think it'll ever go away for a while.
Someone wants to know what type of training you would recommend to get a good grip on Azure Data Factory, Data Lake, Databricks, etc.
Well, Pragmatic works as a partner with Databricks, so we have direct contact with their staff and everything. We're probably working on a course internally for Pragmatic Works to get people up to speed on Databricks, on the information we've learned over time and the best practices. And we have direct access to the Databricks folks. So I would say one of those 2 avenues. We also have courses on Data Factory, I believe, to get people up to speed. Like I said, Data Factory is the plumbing that goes into the ecosystem. So like when buying a house, nobody says, hey, can I look at the pipes and see what are the dimensions and what are the what's the type of metal used for the and all that. Nobody really cares. They look at the kitchen and say, oh, it's got a new fridge or a nice new bathroom. People are really interested in the visuals with the quick wins. Not many people pay attention to the underlying plumbing, but that's where it's at. I mean, Data Factory is a great skill set to have, and I highly recommend it. So if you want, you can contact the training at Pragmatics Works and see if we have something that meets your needs.
Okay, how do you report from Parquet files via Power BI?
Yeah, that's a good question. It's only come up recently. One of the options is to mount it in the Polybase, and we're investigating that now. But essentially, Polybase, so let's say you have a CSV file, a Parquet file, and it's got 25 fields, and some of them are varchar, some are int, some are decimals, dates. You can mount that Parquet file using Polybase, which makes it accessible from the data warehouse. And the Power BI has a direct connection to the Azure Data Warehouse. So that's one method of doing it that we're looking into. I don't think there's a direct connector. I don't think you can connect to Parquets directly. I researched the Avros and the Parquets. You can access the Azure Data Lake 1, Gen 1 out of the box. I think there's a Gen 2 connector, but I wasn't sure if it's in beta. And even if you can connect that, I don't think it'll allow you to connect to the Parquet file. It doesn't know how to read it.
Okay, great. In regards to Polybase, so in Azure, we can join a table with a file on the Azure Blob Storage. The file could be in Parquet or regular CSV JSON.
Yes, you can do just about it. It could be JSON. It could be, as long as you know the structure of the file, you can mount it in Polybase. And in Polybase, you specify the location path, and it can point to a file or it can point to a folder. So let's say you have a month's worth of data, 31 files. As long as the table is constructed with the same column names, column headers, and file format, you can point to a folder, which is really cool because each day that the file gets added, you don't have to refresh anything. The Polybase just mounts it automatically. And you have to specify it if it's a TSV, a CSV, or Parquet, but also you have to tell it the delimiter. Is there a header row? But once you get through that and you start seeing the patterns, it's so easy to create these Polybase files. I think that's one of the best new features from Microsoft that wasn't really promoted as much as far as but it's a great feature.
Someone also wanted to know how you process the tables in your tabular models.
Oh, so we have a couple different methods. We started off with a logic app, and from ADF we call the logic app, and the logic app processes the model. You can also start and stop it. One of the things we ran into was it wasn't seeing the model, and it turned out that in the logic apps there's these 8 IP addresses, and those 8 IP addresses had to be added to the tabular model security So you had to poke a hole for the IP addresses of those 8, and then it saw it just fine. I think we moved it to ADF. So I think we have scripts to do that. I've also worked on other projects where we use the automation routine. Once you can get past the security, any of those methods will work.
All right, great. Well, that was the last question. So thank you, John. We had about 15 minutes worth of questions, so we really appreciate it. The recording will be available right here at this link pretty much as soon as we end the broadcast. The next session is getting started. So if you go to the top left of your screen, you can find it there. We mentioned this as well. I know a couple people are asking. We are going to make these materials and slide decks available within a week of the conference ending, so keep an eye out in your email for that. And thank you, everybody, for joining our first session, and we'll see you in the next one. Thank you, John.
Awesome. Thanks for attending. We appreciate it. Have a great day.